let's do the hard one for you guys. Which is a hard one on this one? Can you tell? Which one's weird? Which one's different? Number 5. Number 5 is a weird one because number 5, you are inside the focal point. Let's try this one real quick. How can we find the image of an object inside the focal point of a concave mirror? You need how many rays of light? 2. Pick one. Ray number 1. Any ray of light that comes in parallel gets reflected through the focal point. Okay? Like so. Boom. Let's try another ray of light. We still don't know where the image is, right? Ray number 4 is awesome. I love ray number 4. It is the lazy man's ray. Yeah. Ray number 4 is any ray of light that comes from the center of curvature gets reflected straight back. So it's going to come in. It's going to hit the mirror. Notice the mirror, it doesn't go far enough, so we'll extend the mirror a little bit. It hits the mirror, and then it bounces straight back. It's the lazy man's ray. It goes right through the center of that circle. So all rays of light, it's like a candle. Think of it like we lit a candle. There's infinite number of rays, but we're only going to pick 2 to find the image. So here's a little problem. Does your eye see the incoming light or the reflected light? Which one? The reflected light. So right away, if the rays don't come together, deja vu. Your brain should not say real image, but what kind? Starts with a V. A virtual image. Take your ruler, extend the reflected rays behind the mirror. That's the key. Because as far as your eye is concerned, light travels in a straight line. Your brain is amazing. It can put together images of light that doesn't even exist. And that's why you see such funky things in a mirror. And where they cross, X marks the spot. This is where the tip of that image is formed. So the rest of it is underneath it. So notice, do we get an upright or inverted image? It is an upright image. Is it bigger or smaller? Bigger. It is enlarged. And is it real or virtual? Is there any light behind the mirror? No. Okay, it is a virtual image. So here's what's kind of cool. When you get inside the focal point of a concave mirror, you are so close to the mirror, you actually can't focus the light. But once you get inside the focal point, you're so close to the mirror, the rays of light can't focus. They get spread out. So your brain puts it together behind the mirror. You get an upright, magnified virtual image. That's why it looks so funny. And that's why a concave mirror is perfect for putting on makeup and shaving and all that. You could enlarge the image to see what's going on. So the opposite of our concave mirror is a convex mirror, which doesn't pull light together. It spreads it out. You can almost figure out what the rays of light are, because rays of light are reversible. Ray number 1 is any ray of light that comes in parallel to that center line. Let me just raise this up on the screen. There we go. If it comes in parallel, here's what's different. This focal point is behind the mirror. It's a virtual focal point. Sometimes you'll see it labeled VF for virtual focal point. So what happens is the rays of light leave as if they were coming from this virtual focal point. The job of a convex mirror is to spread light out, but the key is it spreads it out in a uniform pattern that you can predict. So it comes in parallel, and it leaves at a virtual focal point, as if it was coming from that point there, okay? You know, I bet the artist who designed the cloud gate, the being that we have at Millennium Park, actually sat down a little bit with some calculators and sketches to actually figure out the different focal lengths for the different curves to get some cool, funky effects there. Anyhow, next, ray number 2. You can almost guess. Ray number 2 is the opposite. Any ray of light that approaches this virtual focal point never makes it there. Because who gets in the way? The what? The mirror, right? So we're going to end up coming out parallel to the principal axis. You see that? That's ray number 2. You're going to come towards the focal point, but you never make it. The rays of light would have been focused, but it hits this convex mirror, whose job is then to spread the light out in a uniform fashion. Ray number 3 is annoying. It's hard to draw. That's any ray of light that hits the center point at an angle. We can apply the law of reflection. So if you come in at a certain angle, you're going to leave at that same angle. But that one we don't like to use because you got to use a protractor in order to line it up properly there, right? So instead, let's use the lazy man's ray. Okay, 1, 2, and 4 work really well. Ray number 4 is any ray of light that approaches not the focal point, but twice that, the center of curvature, simply bounces straight back along that line there, that center line. So if you come in towards the center of curvature, you'll leave away from the center of curvature there. And those are our 4 principal rays for diverging mirrors. So, just like before, any 2 rays determine your final image. Let's try it. Ray number 1. Ray number 1 is any ray of light that comes in parallel to the principal axis will leave as if it's coming from the focal point. So just like so. This is ray number 1. Next, we can't find the image. We got to pick another ray. So pick one. Doesn't matter. How about ray number 4? 4 is awesome. It is the lazy man's ray. Late number 4 is any ray of light that approaches the center of curvature bounces just straight back along that center of curvature. It's going to bounce straight back like so. So it comes in towards the mirror, and then it leaves away from the mirror. This is ray number 4. And notice, do these rays of light come together? Do they converge? Or do they spread out? I'm trying to draw an eyeball here. Your eye sees reflected light. Are they coming together? Or are they spreading out? They're spreading out. So as far as your eye is concerned, light travels in a straight line. So if you extend the two reflected rays backwards where they cross, X marks the spot. And notice we're getting a little tiny midget arrow that is upright, reduced, and it's virtual. So in fact, you will always get an upright, reduced virtual image on a convex mirror. It always spreads the light out. That's why if you look in your passenger side mirror, that message, objects in the mirror closer than they appear. And that's because if you run your finger over the passenger side mirror, it's actually slightly convex. It's designed to spread the light out. And on a truck or bus, it's exaggerated. And that way you get a wider field of view, especially for a bus, very dangerous. And it looks like this car is like 50 feet away. But because this mirror spreads the light out, then your brain puts together an upright, reduced virtual image. You might think it's 50 feet away. It's only 20 feet away. So there's a method to the madness there. So you always get this funny, upright, reduced virtual image because a convex mirror spreads the light out.